students. My name is Anjani Garibsingh, and today we are going to do a lesson on subtraction of fractions. Of course, before we start actually doing the subtraction, I have to get a few key ideas, make sure that you understand those key ideas before we can actually subtract. So the first idea we're going to look at is what exactly is a fraction. Now, a fraction is any part of a whole. So this is a part of my teddy bear puzzle, so this is a fraction. At the same time, this is also a fraction because it is part of a circle that I have here. The difference between these two fractions is that in this puzzle, the pieces are different. Some are big, some are small, whereas in this circle, all the parts are equal. Now, how do we know they're equal for sure? What we could do is we could stack all of them together, and you would see that they have the same shape, they have the same size, so they are equal. Now, if they are equal, we learned very early on in class that when we have equal parts, we could name the fractions. Remember that? When we had two equal parts, we call them halves. Very good. When we had three equal parts, we call them thirds. Four equal parts, like I just showed you, we call them either quarter or fourths. Then we go to five equal parts, we have fifths. Then we could go to sixths and so on. So we give them names. We also learned very early on that we could write these named fractions using some mathematical notation. So we had a numerator. I would have a numerator. I would have a vinculum. And I would have a denominator at the bottom. So we could write the fractions mathematically. In addition to writing the fractions mathematically, what you find is that we can now perform some mathematical operations on these fractions. So I can add, I can subtract, I can multiply, and I can divide. But today, our focus is really on the subtraction of the fractions, all right? Now, just to remind you, I just want to remind you of how we did addition. Now, suppose I have two fractions, and I want to add one more fraction to it. When I put them together, what we have is we have 3/4 or 3/4, because each fraction was a quarter. So I can add them, simply put them together, and add count the number of pieces that I have, and that would give me my addition. Our focus now is on subtraction. So we start with a very simple one. We have a whole that is divided into 3 equal parts. Remember what 3 equal parts meant? What is the name we give to 3 equal parts? Good. It was thirds. So if I have 2 of these thirds, I have 2/3. And I want to do a subtraction of that. So I want to subtract 1/3 from my 2/3. So we could write that. The question is, I have 2/3, and I want to subtract 1/3 from that. Now, visually, it's easy because all I'm going to do is I'm going to take that away, and I am left with 1/3. So my answer would be equal to 1/3. Now, if I don't have a fraction circle, I could do it by drawing something that represents my whole. I have a whole. This is my whole. I want to divide it into thirds because I want to get 2/3. So I'm dividing it into 3 equal parts. So this looks about equal, 3 equal parts. If I put it here and here. So what we have is we have 3/3, 1/3, 2/3, 3/3. My question tells us that we're looking at 2/3. So I'm shading what I have. I have my 2/3 shaded. And what I want to do from that, just like I took away the 1/3 here, I'm going to take away 1/3 from my bar. So if I take away 1/3, I'll be left with the 1/3 that we got with the circle. So there are more than one ways that I could actually do the subtraction. Let's try it with another fraction. Here, I have 5/6. You see 1/6 is missing. If we count it, we're going to get 1, 2, 3, 4, 5, 6. So my question here is we have 5/6 minus 3, 6. What would my answer be? In this situation, it's easy because I already have my 5. And what I'm doing is I'm taking away 3, 1, 2, 3, and I'll be left with 2/6. So my answer here would be 2/6. Now, if I were to draw a bar to do the subtraction, we can do it as well. I have my bar. And first of all, we want to divide it into 6, so we could divide it into 3s first. So we divide into 3s. And each third, we divide in 2 to get 6. So I divide this in 2, divide this in 2, divide that one in 2 as well. And you could verify 1, 2, 3, 4, 5, 6, 6. But the question says that we have only 5, so I'm going to shade my 5. 1, 2, 3, 4, and 5. And we now have to subtract 3. So just like I erased here, I'm going to erase 3 of them. So this is 1, 2, 3. 3 of them are gone. So I remain with the same 2/6 that I had with my fraction circle here. What you find is that there's some things that stand out immediately. You're looking at the denominators in this case, and you have a 3, you have a 3, and you have a 3. The denominator here was 6, you have another 6, and you have another 6. So it seems as though when we're subtracting fractions and the two denominators are the same, the answer would carry that same denominator. So we keep that same denominator. Okay, so we settled on what happens with the denominator. What about the numerator? Do you notice anything about the numerator? How the two numerators relate to the numerator of the answer? 2 minus 1 would give me 1. 5 minus 3 would give me 2. So it seems as though we're going to keep the denominators, and the numerator of your answer would be the difference of the two. Let's try another one to make sure. All right? So I have 6/8 minus 2/8. What you expect to get is but because the denominators are the same, your answer would carry that same denominator. So you expect that your answer would be some number of 8s. All right? That takes care of the denominator. Remember what we said about the numerator? The numerator would be the difference between these two. So 6 minus 2 would give me 4. So if we try to verify the answer, this represents my 6/8. 1, 2, 3, 4, 5, 6. And I take away 2. What you remain with is 1, 2, 3, 4. 4/8. So we could generalize now and come up with a rule that we could use. Once we have to subtract two fractions and the denominators are the same, what you expect is you expect to get an answer where the denominator would be the same as the 2 that you were subtracting. The numerator, therefore, would be the difference of the two numerators that you had before, and that goes as a numerator. Okay, so earlier what we did was we looked at how we subtract fractions when the denominators are the same. But you know, when you look at some of those problems in your past papers or in your textbooks, that you have to subtract fractions where the denominators are not always the same. So what would we do in a situation like that? All right, I would show you what we would do in a situation like that. But first, I want to bring you back and recap something that we did in a previous lesson, something called equivalent fractions. All right, now this is half of a whole, and I can find an equivalent amount of quarters that would make this half. So I put 1/4 here, 1/4 here, and I get 2/4 would be equal to a half. So we can write that 2/4 remember doing that? Okay, so if you don't remember, that's fine. What about if I take 6 now and trying to find a number of 6 that would make a half? Okay, cool. So we get 1, 2, 3. 3 6 would be equivalent to a half. I'm going to write that again. So 3 6 is equal to a half. If I use half already, let's use something else. Suppose I take 2/3. This is 2/3, and I want to find out how many 6 would make up my 2/3. I put 1, 2, 2, 1, 2. So we have 1, 2, 3, 4 6 would give me my 2/3. So 4 6 good. So I want you now to see if you could see some kind of relationship that goes on in getting from here to here. Now the denominators are different. They're different, but one is always a multiple of the other. You notice that? 4 is a multiple of 2. 6 is a multiple of 2. 6 is also a multiple of 3. So I multiply by 2 to get to here. If I'm going from here to here, I multiply by 2. So if I multiply the numerator by 2, I would have to multiply the denominator by 2. Exactly. So I'm going to multiply this by 3. So I would multiply the numerator by 3. Same thing happens here. We multiply the denominator by 2. So we're going to multiply the numerator by 2. Want to try one? How about if we had 2/5, and I want to convert that, find equivalent for tenths. We're going to tenths. In going from here to here, I would multiply by 2, right? I know you all know the answer, very good. We're going to multiply the numerator by 2, so we get 4. Excellent. So we are going to use that equivalent fractions now to look at how we subtract fractions when the denominators are different. So the first example I did when we were looking at subtraction, I had 2/3. I had 2/3 minus 1/3, but I don't want to use the same denominator, so I would use 1/6. Okay, so we check. We have a question where we have to work out the difference. We have 2/3 minus 1/6. First thing we check, are the denominators the same? They're not. So what we try to do is we try to get them to be the same. Now we know that they differ, so I could change my 2/3 into some number of 6. You're way ahead of me, right? So I'm going to multiply this by 2, and I'm going to multiply the numerator by 2, so we get 4/6. So my problem up here, which was 2/3 minus 1/6, now becomes 4/6 minus 1/6. We're checking, are the denominators the same? Right? So if they are the same, remember what we did? We kept the denominator, very good. And the numerator was what? The difference across here, which was 4 minus 1, which would give me 3. So we started with things that are different. We ended up with something that we're familiar with, something that we like, something that is easy, and we get our answer. 2/5 minus 3/15. Remember, checking to see if the denominators are the same. The denominators are not the same, so we have to do some kind of adjustment. We have to change the denominators. We have to do the equivalent fractions to get the denominators to be the same, because we know how to work with the fractions when the denominators are the same. So the denominators are different. One is a multiple of the other. So in going from 5 to 15, I would have to multiply by what? 2? No. Multiply by 3. Very good. So I could multiply by 3 here. And if I multiply the denominator by 3, I'm going to have to multiply the numerator by 3 as well. So 2 multiplied by 3 would give me 6. 5 by 3 would give me 15. And we're subtracting 3/15. Checking now, are the denominators the same? Good, right? You're getting the hang of it. So if the denominators are the same, what would the answer denominator be? Excellent. It would be the same as what you had before. The numerator, therefore, would be the difference of these two. So 6 minus 3 would give me an answer of 3/15. All right? What about 19/25 minus 11/25? We are interested only in whether the denominators are the same, right? We have 25 here, we have 25 here. So my answer would have 25 as well, because it would be some number of 25ths. I had 19 of them here, and I'm taking away 11 of them. Remember what we did with the numerator? We simply subtract. So 19 minus 11 would give me 8. So my answer would be 8/25. Do you think you get that? Now, we are subtracting two fractions. When you talk about fractions, we have different kinds of fractions. What are the different type of fractions? You remember? Proper, improper, and mixed numbers. So if I'm going to subtract fractions, I might very well have to subtract numbers that are mixed numbers, different kinds. So we're going to look at what happens in these different cases. So if I have, for example, 1 minus 3/7, again, what we're doing, we're checking to see if the denominators are the same. This 1, I could make that 1 into 7ths. Can we not? Remember how to do that? Okay. So 1 is really 7/7 minus 3/7, and we get the denominators are now the same. So my answer would carry that same denominator of 7, and the numerator would be the difference of those two. 7 minus 3 would give me 4. So you end up with 4/7. Suppose I had 5 minus 3/4. You know what to do when it was 1. What about when it is 5? We have to convert that 5 into quarters. How many quarters do we have in 5 wholes? We have 4 quarters in 1 whole. So you would have that 4 quarters represented 5 times. So you end up with how many quarters? Good. 20 quarters. And you start to smile, right? Because you say, aha, now we have denominators are the same. So we know what to do. My answer would have that same denominator, 4. The numerator would be the difference between 20 and 3, which would give me 17. 17 over 4, 17 quarters, is what kind of fraction? Is it a proper fraction? How you know it's not a proper fraction? Because the numerator is bigger than the denominator. So I could convert that into a mixed number. And how do we convert to a mixed number again? We divide by 4. So 4 into 17 would give me 4. And I have 1 remaining, 1/4 remaining. So your answer would be a mixed number. Okay? So that is how we look at subtraction when you have denominators that are different. We started with these, then we started with whole numbers minus fractions. Now suppose we have mixed numbers. What can we do with mixed numbers? Remember what a mixed number is? A mixed number is 1 with a whole part and a fraction part. So we would look at now what happens when we have a mixed number in the problem. Okay, so what we did before, we looked at working with fractions that had different denominators, but what we're going to look at now is mixed numbers. So if I have 8 and 2/3 minus 2 and 1/12, how are we going to look at a question like that? Now there are different ways that you could look at it. So we'll work with the fractions first. So I'll have 2/3 minus 1/12. What we're looking at, the denominators. Remember, that's the first thing you look at. Check to see if the denominators are the same. The denominators are not the same. So I could change this into 12ths by multiplying the denominator by 4, multiplying the numerator by 4. So it becomes 8/12 minus 1/12. Check again. Are the denominators the same? The denominators are in fact the same. So this minus this would give me some number of 12s. So I retain my denominator of 12. The numerator would be the difference of these two. So I have 7 12s. Now, very often when students do these questions, they forget that what they were dealing with was the fraction part. You have to include also the whole parts. So I would have 8 minus 2 would give me 6. So my answer would be 6 and 7 12ths. That would be your answer. Now that is one way of working the question. Sometimes people use a different way of working the question. They write the first one as 7 plus 1 and 2/3. Check to see. When you add this and this, do you get back 8 and 2/3? Right, I've just rewritten it like that. Minus 2 and 1/12. 7 minus 2 would give me 5, plus I would have 1 and 2/3 minus 1/12. Okay? So that's another way you could look at your answer. If I convert this into 12s, because the denominator are different, I want the denominators to be same. So I would have 5 plus 1. What do I multiply by to get my thirds into 12s? Remember, we did it here. We just did it. So we're going to multiply by 4. So I will have 2 multiplied by 4, 3 multiplied by 4, minus your 1/12. So I will have 5 plus 1 and 8/12 minus 1/12. 5 and 1 would give me 6. 8/12 minus 1/12. We keep the denominator because the denominator is the same in each case. Now, it is very important for the denominators to be the same. So I would keep saying it so that you will remember. The difference, 8 minus 1, would give me 7/12, which is exactly what we got here. So your answer would be 6 and 7/12. All right? So now that we have an idea of how to subtract fractions with different denominators, we want to see how we can rework those in worded problems. So we will be looking at some worded problems in a short while. Right, so now that we know how to subtract fractions, whether the fraction was with the same denominators or whether the denominators were different, we can now apply what we have learned to some problems. Now you find that the problems would start off being very simple, but they would get gradually more difficult. So we start with the first question. So I'm going to read it, and you could read along with me. Jackie had 3/4 of a pizza. She ate 5/8 of the pizza. So she started off with 3/4. She ate 5/8. What fraction of the pizza was left? So you have a pizza. You eat some. What do you expect to remain with? Do you expect to remain with more than you started or less than you started? Obviously, you're going to remain with less. So if you're going to have less, what does less imply to you? What does it seem to suggest in your mind? It seems to suggest that you're going to have to, you're going to have to subtract. So what are we going to subtract? And she ate 5/8. So we have to subtract 5/8. And when we subtract the 5/8, whatever answer we get would be what was left, which would answer the question directly. All right? What was the first thing we have to do when we have to subtract fractions? Right. We check to see if the denominators are the same. One is a multiple of the other. So I could change this fraction, this fourths, this 3/4, into some number of eighths. So I would have my 3/4. I would have to multiply the denominator by 2 to change it into eighths. If I'm going to multiply the denominator by 2, I'm going to have to multiply the numerator by 2 as well. And we again have to subtract 5/8. Working this out, 3 by 2 would give me 6/8 minus 5/8. Remember, every time we have a subtraction, we're going to check to see if the denominators are the same. The denominators are the same, so we're going to retain that denominator. So your answer would be some number of eighths. The number of eighths that you're going to have is the difference of your two numerators. So 6 minus 5 would give me 1/8. So your answer here is 1/8. She'll be left with 1/8 of her pizza. All right? So that is how we work this first question. Okay, so we're on to problem number 2. You see I have my marker in my hand, but before we mark anything, we need to read the question and understand exactly what the question is asking and what the question is giving us in terms of information. So you can read along with me. Ray used 1 2/5 meters of wire to make a shape. Anjani used 2 7/10 of wire to make his shape. How much more wire did Anjani use? So we have two guys making shapes. One, if Ray used 1 2/5, so Ray and Anjani used a little more wire. So Anjani used 2 7/10. Right. What the question is asking is how much more wire did Anjani use? How much more? How much more suggests what? What do you have to do? If I have more than you, and we want to find how much more I have, what does it suggest that you have to do? That's right, you're going to have to subtract. So it's the same thing here. He uses more than Ray, so we're going to have to subtract. So Anjani and the amount he used more would be 2 7/10 minus 1 2/5. That is the amount of wire he used more, right? The difference of the two of them. Now, what you have is you have two mixed numbers that you have to subtract. So we will deal with the whole part first, and then we would look at what happens with the mixed number, with the proper fraction, sorry. So we're looking at the fractions, 7/10 minus 2/5. first thing we check, are the denominators the same? No, they're not. So it means that we're going to have to change the fifths into tenths. To get this into tenths, I'm going to have to multiply the denominator by 2. And as a result, I would have to multiply the numerator by 2 as well. So I will have 7 tenths minus 5 times 2. That would take me to my tenths. And to get the equivalent, I would have to multiply the numerator by 2 as well. So I would have 7 tenths minus 4 tenths. At this point, we check. The denominators are the same, so we say, right, we ready? We keep that denominator of 10. Your numerator, therefore, would be the difference of 7 and 4. 7 minus 4 would give me 3 tenths. Remember, it wasn't just the fractions we were dealing with. We were dealing with the whole number parts as well. So in the whole number parts, 2 minus 1 would give me 1. So my answer, therefore, would be 1 and 3 tenths. All right, so you're following me? How okay, so we're reading the question. Sally used 2¼ meters ribbon to make a bow. Kelly used 1½ meters of ribbon to make her bow. So these two girls making their bows. How much more ribbon did Sally use? So we are going to subtract the 2 lengths minus 1½ Now we know we're dealing in length, so we know that we're talking about meters. So we will put the meters, the units at the end of the problem. Now in this question, I was able to pull out the 2 fractions, the 2/5 and the 7/10, to find the difference, where I took 7/10 minus your 2/5, and it was able to work because this was bigger than that. In this question, however, what happens is I cannot do the same procedure because I cannot take away a half from a quarter. So I'm going to have to adjust the way I do the question. So I have 2 minus 1 would give me 1¼ So that would take care of the 1 that I have here. So I've already done the subtraction of the 1, and I'm going to minus a half. We know how to deal with mixed numbers. In your mixed numbers, what we try to do is we try to get them in a fraction form. Now 1/2 is how many quarters? 4 quarters, and 1/4 would give me 5 quarters minus a half. Remember, we're checking to see if the denominators are the same. The denominators are not the same, so we're going to have to find the equivalent value for 1/2. To get from 2 to 4, we have to multiply by a factor of, right, you remember, we have to multiply this by 2, and we multiply the numerator by 2 as well. So I would get 5 quarters minus 2/4, and the denominators are now the same. So if your denominators are the same, we retain that denominator, and the numerator would be the difference between 5 and 2. 5 minus 2 would give me 3/4 meters. Sally used 3/4 meters more. Now we have our third problem. A lot of the times when you look at your SEA questions, you don't have a single operation to do. Very often, the questions involve more than one operation. So this is a question where you're going to have to do more than one operation. Also, what you find is that there would be more than one way to do the question, and I'll be looking at 2 different ways we can handle the same question. So read the question with me. Gary used 7/16 of his money to buy lunch. He then used 1/8 of his money to buy snacks. What fraction of his money was left? Shall I read it again? Gary used 7/16 of his money to buy lunch. He then used 1/8 of his money to buy snacks. What fraction of his money was left? So we have some information in the question. So we know he used 7/16 on lunch, and then he used 1/8 on snacks. So out of his whole, he started off with a whole amount of money. It doesn't matter what the whole amount of money was. He had a certain amount of money, and what he did was he used 7/16, and then he used 1/8. We want to find out how much was left. So we need to first find out how much he used in total. So the total amount used would be the sum of these two Now you know how to add fractions with different denominators. It's just like when we were subtracting. What we do is we convert this to a certain amount of 16ths by multiplying by a factor of 2 and multiplying the numerator by 2 as well. So you're going to have 7/16 plus 8 by 2 to give you your 16ths in your denominator, and I'm going to multiply the top by 2 as well. So you have 7/16 plus 2/16. The denominator are the same, so we just add the numerators. So this would give me 9/16. So he used 9/16 of his money. We want to find what fraction he was left with. So he was left with remember, he started off with his whole sum of money, so that would be his whole 1 minus 9/16. Right? Remember, we did questions like that, where your 1 could be written as a certain number of 16ths. How many 16ths would make a whole? Very well. So I would have 16/16 minus 9/16. The denominators are the same, which is what we want. So your answer would be some number of 16ths. So your numerator, therefore, would be the difference between these two. 16 minus 9 would give me 7/16. So Gary was left with 7/16 of his money. All right? So that is one way we can work the question. We are going to use a second method to solve the same question. So I will read back the question so you understand what we are doing. Gary used 7/16 of his money to buy lunch. He then used 1/8 of his money to buy snacks. What fraction of his money was left? So our method 2 involves using a bar to represent our whole. So this is my bar. And that represents the amount of money that Gary had. Now, we are told that Gary used 7/16 of his money to buy lunch. So we have to divide our whole into 16 equal parts. Now we do this systematically. We divide it first in half. So I have 2 equal parts. Each of the halves I divide in 2, so I will get quarters. 1, 2, 3, 4. Each of the quarters we divide in 2. 1, 2, 3, 4. So I've divided the 4 quarters into equal parts, 2 parts. We want to go on to 16. So I'm going to have to divide each one of the little 8s into a half as well. So I get half, 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 half. All right? And we could check, we could verify whether we have 16 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces. So we divide it first in a half, divide again into quarters, divide again into 8s, then divide into 16s. Now Gary used 7/16, so what we're going to do is we're going to shade the 7 that he used to buy lunch. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. That is your 7/16. Once you've gotten your 7/16, now we're looking at how much he spent on snacks. He spent 1/8 on snacks. But our bar was divided into 16s. So how many 16s would make 1/8? Difficult? No. To get this to 16s, we just multiply by 2. So I multiply the numerator by 2 as well. So 1/8 is really 2/16. So we knew that he used 7/16 on lunch. That is gone. He also used another 2/16 on snacks. So what he was left with would be this piece that was not shaded. And that would be 1, 2, 3, 4, 5, 6, 7, 16ths. So Gary was left with with 7/16 of his money. All right, students, now we can all smile because this is the last question that we're going to do in today's lesson. It is by no means a difficult question, but it involves a lot of thinking. So what I want you to do is I want you to look at the question, read the question along with me so that you would understand exactly what is given to you and what you have to find. All right? What I want you to know as well is I would go through 3 different methods of solving this question. So read along with me. Sati had 480 oranges. She sold a quarter of them on Saturday. She sold 2/3 of the remainder on Sunday, how many oranges did she have after the weekend? So she sold some on Saturday, she sold some on Sunday, and we want to find out how many was left afterwards. Now, how many, when you talk about how many, it seems to indicate that you have to find a number, all right? So we're looking at the different methods. So the first method involves working the question with a bunch of numbers. We could convert each step into a number. So Sati started with 480 oranges. The number sold on Saturday was a quarter of the 480. So I would take a quarter multiplied by your 480, and we could do that using our mental math. 4 into 48 would be 12, so 4 into 480 would be 120. So 120 oranges were sold on Saturday. After 120 oranges were sold, we talk about the remainder. So we have to bring in what remained after she sold on Saturday. So she was left with 480 minus the 120 that she sold. Again, we could use some mental maths. 48 minus 12 is equal to 36. So we could extend it. If we have 48 tens and 12 tens, we will get 36 tens, 360. So she was left with 360 to proceed to sell on Sunday. So the number she sold on Sunday was 2/3 of this 360. Remember, that is what she was left with. So we find 2/3. All right, so 2/3 of your 360. 3 into 36 would give me 12. But it's 12 with a 0, so we have 120 by 2 would give me 240. So on Saturday, she sold 120. On Sunday, she sold 240. Was, remember, 120 from Saturday. And from Sunday, we had 240. So using our mental math, we know 12 plus 24 would give us 36, but it's not 12 we're dealing with. We're dealing with 12 tens and 24 tens, so I will end up with 36 tens. We have to be careful. Is that what we were asked to do? How many oranges did she have after the weekend? So this was what was sold. So she had the remaining was 480 minus 360. So she was left with 120 oranges. So your answer was 120 oranges. That's the first method. So this one was a numerical way of working the question. We look at the second method. It's the same question. She sold a quarter on Saturday, 2/3 of the remainder on Sunday. How much did she have remaining? The second method, we're looking at the fraction that was sold on Saturday. So the fraction sold was a quarter. And on Sunday, 2/3 of the remainder was sold. So we have to find out what remained after a quarter was sold. So the fraction that remained would have been 1 minus a quarter. We try to get the denominators to be the same. So we have 4 quarters minus 1 quarter will be 3 quarters. Now I know a lot of you know to do that mentally, all right? So there were 3 quarters of the oranges remaining for Sunday. On Sunday, the fraction that was sold was 2/3 of the remainder. The remainder we had was 3 quarters. We tried to reduce that. 3 into 3, we have 1. 2 into 4, we have 2. So we find that a half of the oranges were sold on Sunday. We want to find out how many oranges remained after the weekend. So we know a quarter was sold on Saturday, a half was sold on Sunday. So the amount sold would be a half, which was sold on Sunday. That's your half from here, plus your quarter. We could change all of them to the same denominator. A half could become quarters because we multiply the denominator by 2. So I would multiply this by 2, multiply the numerator by 2. So I have 2/4 plus 1/4, giving me 3/4. So if 3/4 was sold for the entire weekend, what was unsold would be the whole minus your 3/4. A whole is 4 quarters. So you're going to have 4 quarters minus 3/4. The denominators are now the same, so we just subtract the numerators. 4 minus 3 would give me 1, and we retain the denominator of 4. So she was left with a quarter of her oranges after the weekend. How many oranges did she have remaining? So we have to convert this quarter into a number. How many? So unsold, number unsold would be a quarter multiplied by 480. Nice numbers. 4 into 48 would give me 12. So you have 120. 12 here with a 0. So you have 120 oranges. So this is your answer. Your answer would be 120 oranges. Okay? So what we did today in summary is we looked at subtraction of fractions. Sometimes the fractions have the same denominator, which is easy in that all we have to do was to keep that denominator and subtract the numerators. In the more difficult circumstance where the denominators were multiples of each other, what we had to do was we had to get them having the same denominator by multiplying by a factor. And once we got the two denominators being the same, we just subtracted the numerators across. We also looked at applications of what we did on subtraction. We did some multi-step, we did some single-step questions. So that concludes our lesson for today. And I hope you spend some time practicing some of these questions, and we will see you another time.